Good morning and welcome to the OxTS webinar on post-processing with NAVsolve and NAVgraph. We'll get started in about 2 minutes time. Good morning, thank you for joining us and welcome to the OxTS webinar on post-processing using NAVsolve and NAVgraph, which will be run by my colleague Sam. There will be time for questions at the end, but please ask any you have as we go using the questions box and we'll get through as many as we can. Anyway, over to you, Sam.
Thank you, Caroline, and hello everyone. Welcome to this webinar on post-processing with NAVsolve and NAVgraph. The webinar will have two parts. We'll first have a short introduction to what NAVsolve and NAVgraph can do, and then we will have some practical examples. So NAVsolve and NAVgraph main features in NAVsolve are, first of all, obviously that you can open RD files that are logged in with OxTS units. You can preview the data, so have an initial idea of how good the quality of your data is, and also you can have some information about the file and the unit itself, so what kind of feature codes were enabled, what kind of firmware the unit had on, this kind of things. This kind of information might be useful at times for troubleshooting. You can choose what processing mode you would like, that's simulated or combined. We will have more on that in a minute. You can add RINEX files, so differential corrections files, to improve the accuracy of your data. You can modify the configuration, so whatever configuration you had in real time that you've logged your data with, you can modify that either because you realize that the configuration was wrong in some aspects, or because you want to check the effect of modifying a few settings. NAVsolve generates the processed files, which are in the format of NCOM, which is the most widely used, or MCOM or XCOM files. These are all files that contain the processed data. You can export the data, the processed data, in some other formats, mainly CSV. So you can visualize that in a third-party software. And finally, you can do batch processing. So basically, everything that you can do with a single RD file, you can do with a group of RD files. Instead of doing that, repeatedly for every single file, you can do that at once for all of them. NAVgraph opens the processed data, so the NCOM or MCOM formats, and can also open the RCOM, which is, if you are familiar with our RTO range system, the RCOM is the range processed data. It can display data graphically and numerically. We'll see examples of that. You can choose what you want to display. Our systems provide a huge number of parameters in the hundreds, so obviously you can select which specific data you are interested in and just visualize that one. If you use NAVgraph time and again, and you are always interested in the same kind of data, you can create your own template whereby you save just the data you are interested in, so you can visualize only that. We also have some default templates that are already saved and come with the software, or you can download them from our website. We will have examples of that in a bit. As I said, these are the templates that you can have. They either come with the software or you can download them from our website. You can zoom into the data. So if you're interested in specific portions of your data, you can focus on that, zoom in, and only visualize the data for that. NAVgraph also offers the possibility of exporting CSV files and KML files, which are the trajectory files that you can visualize in Google Earth. So NAVsolve, those of you that already had a look at it would have noticed that it shares the same look and feeling with NAVconfig. That's because the two softwares can interact between each other, and you can open NAVconfig from NAVsolve, as we will see in a minute. The navigation panel is on the left, so that is the different sections of NAVsolve that we will go through. The source one, first of all, obviously, this is where you select the data that you want to process. It can be directly downloaded from a live unit, or it can be a file that is saved locally on your machine. You can also open directly NCOM files, so data that is already processed. That will take you directly to the export section. The preview, this is, as I mentioned, where you can check and the initial quality, say, of your data. So you can have a look at what kind of device you had on, what feature codes were enabled, what firmware was on. You can also have a look at the graph and an initial plot of the data, and you can check the integrity and some information on the data packets in the file. So you have a quick idea on whether your collection was okay or whether you had some issues. The process section, this is where you can select review configuration if you wanted. So as I mentioned, you can modify the configurations that you had in real time. You can add RINEX files to improve the accuracy. You can select what kind of processing you want, simulated or combined. The export section, this is where you select, first of all, what kind of file, so the formats, and what contents, so what kind of parameters you want exported. If you had triggers in real time, you can use them to shape your file. So you can have, for example, just data on triggers instead of have your data output periodically at a specified frequency. You can have the data just when a trigger came in, or you can use the triggers to chop your export file into smaller files that will start and end at triggers. Obviously, you can specify, you can zoom into your data and specify portions, sections of your data that you want to export. So you set the start and end point. Finally, batch processing, as mentioned, this is basically, it allows you to do what you can do with a single file, but with a group of them. So batch processing options, meaning the kind of processing that you want to use, if you want to add the RINEX files to improve the accuracy, and what kind of messages or parameters you want to export into a CSV or another format, or for a group of files. NAVgraph, this is how it looks like. We will have a practical example, as I mentioned, in a bit. So the main section is the graph, where you can visualize the data, have a quick understanding of the trend of your data. This is the accelerations, for example, graphs that you are looking at. On the left, you can see the trajectory that you have covered, so it gives you a quick idea. The table, that's where you can visualize the data numerically. And finally, on the right, some information on the files you are visualizing. This is especially useful if you have many files open at once, so you can distinguish in between them and have information on which is which, how the NCOM file that you are visualizing was generated. Was it a simulated processing, a combined, a real-time, perhaps trace? So all of this you can see by hovering over the file name on the section on the right. Okay, that's it for the presentation. And what I'm going to do now is, as I said, have some practical examples. So we will have some RD files to open, some NCOM files to open in NAVsolve and NAVgraph. So let's start with a single RD file. If you double click on that, the software should automatically associate RD files with NAVsolve. So the first time you install the software, you might get a the system might ask you whether you are happy to open RD files with NAVsolve, and if you just click OK, then it will always associate RD files with NAVsolve. So you just have to double click on an RD file to open it in NAVsolve. So first section, as we described, is the source. This is where you select the source of your data. In this case, we have one RD file that you can see here that is locally saved on my machine, but you can always select, as mentioned, a live unit if you are connected directly to an RT to download RD files from it, or select a processed data, NCOM data. In this case, we only have one file. We will have an example of batch processing in a minute. So the preview section, this is when you can have a look at product details. So that was an RT3000 V3, the firmware version that it had on. You can have a look at what sort of feature codes you had enabled or not supported or disabled, so you realize what your system is capable of, and a hardware configuration. So basically it's all to tell you about what sort of unit it is, what hardware it had on, what kind of IMU, what kind of GNSS receivers, this kind of things. In the graph section, in fact, if I maximize this, it's probably better. As you can see, you have a quick, basically, overview of your data. So that is the speed plot of your data, and this is the initial trajectory that you had. It's not, a detailed one, but it's just to give an idea, an overview. And also at the cursor point, it tells you the values of a few parameters, mainly related to GNSS and IMU, so you can realize if anything is wrong with it. If those values do not make sense, you can quickly realize that something was not okay. Otherwise, nothing to flag, so the data collection was all right. In the data analysis section, you can have an idea of the size of your file, how many bytes you had, if you had any sync errors or byte discarded. That was not the case here. And the packet matrix, it's tell you the details of those packets, how many were GNSS, how many were IMU, this kind of things. As I said, most of times you won't really care about this kind of things, but in case you are troubleshooting, then that might come handy. The process section. So one of the main features is that you can launch NAVconfig basically by hitting the review configuration that you can see here. This what will do, it's basically will open NAVconfig. It will launch automatically, as if you were connected to a live unit. And then what you can do is either improve the config. So if you've done a warm up and you process the data in post-processing, so you can extract the improved configuration from the file instead of having that from a live unit. Or what you can do is also modifying the configuration. So if you just click here, it takes you to the configuration you had in real time, and you can basically change it, play with it, either because you realized it was wrong, or because you want to check the effect of introducing a different settings. Okay, we will not do that now. Another important thing is the source of the configuration. You can see configuration here from raw data, that is from the RD file itself. Alternatively, you can select from a file. If you have a different config that you have saved on your local machine, you can load it directly from here. Okay, another thing that you can do in the process section before you hit process is selecting a RINEX files. You can do this in two ways. Either you have it saved on your local machine. So what you have to do is basically browse to that file. So for example, that would be, in this case, we would have a file here that I've saved. You see, it appears here, local, etc. So that's one way of doing that. But also another thing that you can do is trying to search for RINEX files online if you want it. So, for example, if you that's just an automatic routine that the software runs. So if you want to look for some RINEX files close to where your location is, you can start from a radius of 10 kilometers. So I've launched it, and as you can see, the system is telling me that no base stations were available within 10 kilometers. So I can change that to 15, search again, and here we go. You can see that a second file from Oxford did appear. I might change that to 50, search again, and here we go. You see a bunch of other files because more base stations were available. So if I'm interested in one of them, let's say I'm gonna go with the Oxford one because it's the closest to where I am. Here we go. So I just need to click download. Now it is available for me to use, and I can tick it. So I can use this RINEX file for my processing. Another thing that you can do if you haven't configured your local coordinates in real time, so in NavConfig directly, you can add them now. You just need to drag the cursor at one point, on your trajectory, and then hit set origin here. And this will basically configure the origin and the direction axis of the local coordinates if you didn't have them. Another option is to open, as we've seen, to review the configuration and go to local coordinates and enable them there. But it might be quicker at times to do it directly from here. Some advanced settings, things that you care about if you are processing in combined, you wanna have enable advanced smoothing. Keep in mind that this will take a bit longer, so use it only if needed. You might want an MCOM file instead of the classic NCOM format. One thing that I'm going to do now is to hit the display results in NAVgraph, so it automatically opens NAVgraph once I'm done with it. So here we go. I've set my local coords. I've selected my base station file. Back to the process tab, and here is where you can select what kind of processing you want: simulated, combined, or both. So I'm going to stick with combined. And when I hit process, you will see that initially it just had to cook the data, as we say, and then it will start processing both traces. So you see on the left you have the forwards one, and on the right that's the backwards one, that are being processed in parallel. What you see here is basically the process log. So as it goes, it tells you that it did find the base station. Here it is over there, the coordinates of the base. It is telling me how it did initialize. It is telling me that about some real-time commands that have been sent in real time. What kind of initialization did I have? Was that a forward heading? So that is dynamic init, or GPS heading, that would be static initialization. Then once it is done with both processing, as you will see in a second, it will merge them together to provide, here we go, the forwards has already finished. In a second, the backwards also will have completed its processing, and we will enter the final. If you are processing in simulated mode, you will only have basically one section, because it's just one direction. Simulated is pretty much similar to forwards, but because I've selected combine, because I wanted to show you this time around, you basically have both of them. And here we go, that's the phase where the system is putting the forwards and backwards traces together in order to obtain the combined processing. And at the end, as soon as it is done, now the system will launch NAVgraph automatically, because I've selected that, I ticked that box, so it will open up NAVgraph automatically. Let me just drag the window that I had on a second screen just to show you that. Here we go, this is NAVgraph window. So we will come back to NAVgraph in a second. I just wanted to show you this possibility of launching it directly, so you don't have to bother clicking on the NCOM file to open it at the end. Okay, that's for the process section. We can go now to the export bit of it. So the first thing it's asking you in the first page is, well, the format of the time. That's fine. So you can Most of the times you can leave the default, hours, minutes, seconds, and decimal places. Then it asks you to select the start and stop time. So it says here, select from graph. So if you go to the graph, you can move the start and end. So the green one is the start, the red one is the end cursor. This one just show you, it basically plots over here some of the data that you are looking at, so we realize what the values are. So basically you can move the start and stop around. So you specify where you want to start and end your export. Here we go, it has updated the tab accordingly. You can select the frequency. You can go up to 100 Hertz or 250 Hertz if you have a unit capable of that. So we'll leave it at 1 Hertz now for simplicity. And you can select a few formats. As I said, the mostly widely used is the CSV. Files. So typically you can select export to main output file. This will output periodically. So for example, at 1 Hertz as specified. But I can also have the option of exporting to trigger files. So either you export on triggers only instead of having that periodically, or you use the triggers, as I said, to chop the file and divide it into smaller sections based on trigger times. The measurement, this is where you select what kind of measurements you want. So if you are not happy with something, for example, you right click and delete it. And if you want any more, you hit add measurements, you select your section. So say I want latitude, I already have longitude, so I want altitude as well, say, and I go add, and here they are. And also if you want your columns in the CSV file to be in a specific order, then you can shuffle this data around here. As you can see, you can bring time up and down. So you already set the order of the columns, and so that you can have it exported in the way you wanted it. And also with some measurements, you will have a choice of units, depending, what we are looking at. If you want the latitude, for example, in degrees or radians, meters, inches, feet, speed, you can have that in miles per hour, kilometers per hour, and so on. So once you have selected all of this, all you have to do is just to hit export down here, and we go, the data has been exported. We'll see in I guess, yeah, I'm going to use a different example for batch processing. So we can close NAVsolve now. And just to show you, this is the process folder. That's where this is the same folder where the RD file was. So that's where we started. If you open the process, you will find a folder that contains the base station files that you have used. Here it is, the Oxford one. The 3 traces, backwards, forwards, and combined. See, each one will have its own NCOM, its own processing results. And here is the CSV file that I have exported. So I'm gonna open it quickly just to show you that the data is actually there. Here we go. Okay. So now that we are done with this, we can have an example on batch processing. So as you see here, I've saved 3 files instead of 1. The files do not have to be necessarily from the same unit or the same day or the same location. They can be files from different RTs collected on different days in different locations. The difference would be that in the search tab you will have to select all of them. Then in the process tab, if you are using base stations, let me just maximize this, you just have to set over here the radius of the search that you want to apply to these RINEX files. Okay, the system will automatically search based on the location of each of the files. It doesn't have to be, these are the files that I had earlier, but I'm not going to select any of these. I'm just going to leave it for the system to search automatically for RINEX files. As I said, the system will, you see, if you select here auto download, will automatically set the origin of the search based on the location of the RD file. So you don't have to worry about it. The system is, say, intelligent enough to apply the relevant RINEX files to the relevant RD files. In the export section, if you want to add some measurements, so for simplicity, I'm going to select acceleration X, Y, and Z. add, and here we go, I've got it, and this is it. All you have to do now is just hit batch processing, and you will see that the system will look for base station. If you look down here, you see the first thing it does is searching for base station for files 1, then downloading them, then processing the first file, files 1 of 3, and then it will export the data, that I have specified in the export measurement section. As soon as it's done processing, and exporting. Okay, it has done that, so it moves to file 2, searching for the base stations, and as soon as it finds them, it will start downloading the files. So all that we have done, and I've showed you for a single RD file, you can do for any number of them, really. The only thing that will change, obviously, is the time that it will take the system to process, depending on how many you've got, and obviously how big, how large the files are. So I'm just gonna leave it a few seconds. This is basically doing all of that combined processing, by the way, which is obviously a bit longer than just simulated for 3 files. But as you see, it just take about a minute or so for each file. Besides, like if you have other things to do in the meantime, you can just leave it to the system. As you can see, it takes care of itself. Do all you need to do, and then I'll show you in a second. It will save the files in relevant folders, and then at the end, here we go. We are done now. We can close down NAVsolve, and in our folder, you can see we find the batch process folder. So there is a folder for each of the 3 files, and inside it, here we go. Again, you have the 3 traces as I showed you, the CSV file, that's the export, and the base stations. Just want to show you this. Perhaps you can check the names, say, of these base stations, but what you might be able to realize is that the number of base station is different from file to file, because depending on the location the RD file was logged in, obviously a radius of 50 kilometers might have found, search area of 50 kilometers might have found more or less files. So this is just to show you that the system doesn't apply stupidly the same RINEX files to all RD files. It applies only what is relevant. So it searches, finds, and applies just what is relevant for each RD file. Okay, just as an example, say this is the 3rd one. Let's have a look at the CSV file just to make sure that the export is indeed there. So it does all of that for all of them intelligently, say. Okay, so we can go directly to an example in NAVgraph now. So let's open this trace here, the simulated processing. It's a file that I've processed now beforehand so that I can have things ready to show you. And so we can have a look a bit at what you can do in NAVgraph. So the default template NAVgraph will opens up with is always the speed trace. As we discussed in the presentation, this is the trajectory that you've covered. This is the table, and that's where you have some more information. I'm going to load another file in a minute, so we can, you can see the utility of this. If you hover over this, it will tell you some information about the file. So especially when you have many files, that can come handy. So here we go. That's the speed trace. So the first thing that you can do is right-click and configure graph. And this is where you can remove or add measurements. So say in addition to speed, I wanted, for example, my position mode. So I can just tick it, add it. I can choose the color I want to display in. Red is fine. I can make the trace thicker. I can select the axis, so I don't have all my stuff on the same axis. On the y-axis, I can select, a name for it. So for example, instead of calling it axis 1, I can have something that is more meaningful. And here we go now. So speed, and as you see, level 3 here, that's position mode, that is equivalent to SPS. So another thing that you can do is zoom in. So if I select this, I can move my cursors around, right click and go select region between cursors, so it will zoom in and just show me the data for that specific section that I have selected. These are the templates that you can select. So that the speed templates I'm visualizing, but say I wanted to look, for example, at accelerations, XYZ perhaps. So you just click on the template and it will load specific measurements according to what the template did contain. As I mentioned, you can customize this and create your own template. So here we go. I've got, this is acceleration on Z, so gravity basically. And as you can see, because I was doing a lot of figures of 8, the red line is the lateral acceleration. And as you can see, it's going up and down. The green one is, light green is accelerations forward. So because I was accelerating and decelerating, you can see it again, acceleration going up and down. Okay, in the table, as you can see here, you have a number of measurements. You can also configure, customize the table, so you can delete any measurement that you are not interested in simply by hitting delete, say like I'm doing now. And if you want other measurements, you just click on add measurements and you add them. Here we go. You have modified your table. So things that you can export from the from NAVgraph. First of all, you can select to export another NCOM file or a binary file that is just the section that you have selected. So if you, like I've done, you zoom in and then go export binary file, what you will have is an NCOM file that, instead of being the entire thing, is just the section you are interested in. Other thing is the CSV, the same as with NAVsolve. What you get in the CSV file is what you have in the table. So you can customize the table first, select the frequency you want the data in, and then export. We will see in a minute, I'll show you the output. And finally, you can have KML file. So again, you can select the frequency. In fact, might be nicer if I export the KML of the entire trace. 20 Hertz, say we want this in red. Okay, so now it is exporting the KML data. And because the option was selected, it will automatically open Google Earth. Zoom in on our testing ground. And here we go. Let me set this right for you. And that's the whole trajectory. And this in here is the section that I was zoomed in. If you recognize, the figures of 8 that we had earlier. Okay, no need to save. Just to show you that we've got, this is the KML file. This is the CSV that I have exported with just, a few measurements, lat, lon, alt, and another one, I believe. So just to show you that, here we go, the data is there. And this is the, the NCOM, the limited NCOM one, the simulated page 1. So that's a smaller, you can tell also by the size, that's just about 2 megs instead of being 17. Okay, one final thing I want to show you is, can just close down this one, leave the speed, and let me just drag the window in the right place. So this is the file open, the simulated file, you know, that I have processed until now, this one basically. So I'm gonna load the combined file as well. That is basically the same processing, but for both of them. Obviously, they will be on top of each other. So, for example, if you wanted to distinguish them, if you hit configure graph, I'm going to have now my speed for the second one in, say, blue, and that will put it on top of the other one, so you can distinguish which is which. Speed will not be very significant. It will be pretty much the same. As you see, just change color. What I'll do is just load another template, which is position accuracy basic. That's the last thing I want to show you, just for some difference, say, between the combined and the simulated processing. So as soon as the template is finished loading all its stuff, what you have in this template is some information on your position accuracy, position mode, the number of satellites that the system was using. So if I go configure graph, and I'm going to focus just on position accuracy, so untick all of this thing. As you can see, you can customize a lot. I'm going to leave this in green. That's position north and east for the simulated, and have in red the post-process combined position accuracy north and east. So all you have now is just position accuracy north and east for both the simulated and the combined processing. Just give it a second for it to load all the information it needs. And here we go. So if I change the scale of this so we can have a better idea, this is what I wanted to show you really. As I mentioned, the accuracy in green, that's your simulated. You can change the time here to be seconds from midnight Sunday instead of time from initialization, because they might have initialized at different times. Here we go. So it's just the impact that the combined processing can have on accuracies. This is at a level without even applying, you know, RINEX corrections. So as you can see, this is the accuracy here of the green one. That's the accuracy of the simulated, and this is the accuracy of the combined. What you have here at the end is a bit where the backwards trace did not initialize yet. So all you have here is forwards, and as you see, the accuracy is the same as simulated pretty much. Same way here, you know, I've left this cursor level so you can check that the value is the same. Here the forwards one did not initialize yet. So what you have here is just the accuracy of the backwards trace, and again, it's pretty much the same as the simulated. But when the two traces, forwards and backwards, come together, you can see that they improve each other, and the combined accuracy, you gain about 10 centimeters of position accuracy. So instead of having 25, you're around 15. Okay, just because you no RINEX files, nothing else, just because the two traces are coming together and improving each other. So that's the power, say, of the combined processing. Okay, I guess this is it. Thank you.
Thank you very much, Sam. That's very well presented. We don't actually have any questions that we haven't already answered as you've gone. So we do have 5 minutes if anybody else has got anything they want to ask. Otherwise, thank you all for joining. This has been recorded and you will get a copy shortly afterwards. This is the last time I think that this webinar is run, but Sam will be running some, or am I incorrect with that, Sam?
Yeah, it is correct. That was the last webinar for NAVsolve and NAVgraph. Obviously, the recording will be available. So
yeah, but there are some new ones being run throughout the month of May. So please go into the OxTS site and have a look under the resources hub for the new webinars that we're running. Anyway, thank you all for joining. I hope you find it useful.
Okay, thank you everyone. Have a good day.